Hey there. Let's learn some VEX and how to incorporate it in our procedural modeling workflow. I'm Matt Wagar, and I'm a games intern at SideFX. I've recently graduated with a degree in computer science, so when I was picking up Houdini, coding just came naturally. I didn't know all the nodes in Houdini at first, so when in doubt, I'd just make it in VEX. VEX is super powerful and high performance, even more so than VOPs, so whether you want to do something simple or complex, chances are Houdini can render it super quickly. If coding is not your thing, don't worry, this walkthrough is made for beginners and advanced users. You will, however, need to at least know data types, if statements, and for loops. Let's begin. What is VEX? VEX is a high-performance C-like programming language for writing custom nodes in Houdini. To write VEX, create a wrangle node and select what data type to run over: points, primitives, detail, vertices, or numbers. You can also write VEX in other types of nodes, such as volume wrangles, as well as height map wrangles, and so on. But for procedural modeling purposes, you probably only want to use attribute wrangle. There are 3 ways to create custom geometry nodes in Houdini: VEX, VOPs, and Python. VEX is the fastest of the 3 and is very useful for editing geometry data. If you want to edit specific points on a primitive in your geometry, VEX can do that easily. Not to mention, it's good at creating geometry such as polylines. VOPs has many built-in nodes such as color blending and unified noise that make creating things such as shaders very easy. VOPs are also visual and require no scripting knowledge. Python has access to all of Houdini's functionality instead of just your current geometry. This is very useful for creating rigging controls or parsing files. Python, however, is the slowest of the 3. Here are some functions that I wish I knew when I was first starting out in Houdini. CHF, CHB, and CHRAMP create channels for floats, vectors, and ramps. Channels are like properties or sliders, or as you can see in the top right image, a ramp that lets you edit data and see it live in the scene view. Set is used for setting dynamic data onto things such as strings or vectors. So for example, if you wanted to mix and match your vectors together or concatenate strings together, you would use the set function on a string or vector variable. Point, prim, and detail functions are used to get attribute data on a specific point, prim, or detail. Endpoints and endprims is the total number of points or primitives on your geometry. This is useful for looping through all of the points or primitives on your geometry. Add point, add prim, remove point, remove prim. Adds or removes those points. Keep in mind that if you're running over points or primitives, this won't be added to those that are getting run over, so be careful. Set point attrib and set prim attrib sets the values on existing points or primitives. Fit and lerp are used for editing floats or vectors. Fit takes a float or vector and scales it from one range to another range, and lerp takes a float or vector and gets a point in between those two. Distance gets the distance between 2 points. And lastly, cross, dot, and normalize. These are a little bit more advanced, but they're very useful for dealing with orientation or normals on your geometry. So now I'm going to show some simple examples of how to use VEX in Houdini. First, I'm going to create a geonode. I'm going to create a sphere. I'm going to access the properties of that sphere and set it to polygon mesh. Now we can see the points on the mesh, as well as the primitives. I'm going to create a wrangle, or an attribute wrangle node. In this wrangle node, I'm going to set the attribute CD to be 0, 1, 0, And what this will do is it'll make it green. What this @cd is it's adding an attribute to the mesh on each of the points and adding 0, 1, 0 RGB, where G is 1 and red and blue are 0. And we can see that in the geometry spreadsheet, 0, 1, 0, whereas before in the sphere there's nothing. Another built-in attribute we can add is @n, which is for the normal. And setting it to 0, 1, 0 will make the normal face upward in the y direction, which means when we look at it here, when we look at the top, it's fully green, but when we look at the bottom, it's black. And we can visualize that with the display normals button here. All right, so let's make another geometry using a few more of the functions I mentioned before. We're going to set the points to 10. I'm going to create a wrangle, attach it to the wrangle. It's going to run over the points again, and this time I will create a custom attribute called @rampNum. I'm going to set it equal to fit @ptnum. ptnum is each point in that it runs over in the wrangle. So from 0 to 10, because we set that to 10 points on the line, as seen here. And it'll go between a range of 0 to numpt to 0 to 1. It'll scale it. So numpt is 10. Numpt is just the number of points on the geometry. And now we will get 0, 0.0, 0.1, 0.2, 0.3, all the way to 0.9. Next, I will create a float called grad, or gradient. Let's go with that. I'm going to use the chramp function. I'm going to name my ramp gradient, and I will feed in the ramp num. And now, when I click this button, it will add a ramp to the interface. And we can move it up and down to change the ramp. However, to see this in the scene view, we will use that @cd again so that we can see it, visualize the color on it, or gradient. And now it's from black to white, 0 to 1. So when I move this down, it's now black, 0 to 0. Move both of these up, it is 1 to 1, and so on. And this is very powerful to be able to easily just set the gradient on each of these points. So now I'm going to go over an asset that I created during my internship, utilizing many of the functions, including the ones I just showed you here, on a hanging bridge. All right, so here's my Houdini Digital Asset for a hanging bridge. And this is my node graph for it. I have it separated into different sections for each of the parts, and I have this final section that just combines each of the different parts together and merges them to create this. First, I started off with just the curve, because that is what Unity will use to create the bridge in whichever way I want. Next, I have the bridge steps that look like this. All that I'm really doing here is that I'm just making a curved line, and I'm copying each of the boxes to the curve. But I do use a little bit of VEX in here for removing the endpoints that look like this. So if I wanted to shorten it or make it longer. And all that I'm doing here is that I'm just checking to see if it's in the range of the remove points at the start of ptnum or at the end of ptnum, using numpt for the total number. And that just shortens or lengthens it. And the reason that I want to do that is so that on the output, I can make sure that this is lined up just correctly. All right, next part, we have the pole. On this, also, it's mostly just taking a line and sweeping it. However, I also did a little bit of VEX here so that I can set up some middle points between the line. And I'm just setting, in my add, I have 5 points. And then inside of here, I lerp those points from the start to the end to get a start, end, and middle point. And if I move it up and down using this channel, I can set where the ropes will spawn. Next, in the side rope section, I will create all of these side ropes as well as the poles. So first I have these. So first I take the curve at the start. Let's lengthen this. We take the curve at the start and I create right vectors coming out of them that look like this. And the way I do that is that I just get the cross product from the first and second point and the fourth and third, and get the up vector, and that will get me the right vector, which will be used then right over here to create 4 more points. I use the add point function to create 4 more points that are away from the center. And I use this distance channel that is using the amount that we are offsetting the box here. So if I increase this, it'll increase the point distance there, which then if you see on the final model, it will offset everything together when you move this one variable. All right. Next, I am putting those points at an angle. You can't quite see them because they're still points, but this will be useful when by putting it on the orient attribute when we use copy to points, because then when we put it at an angle, it will rotate these when we copy to points. The way I do this is I create another cross product from the center to the point of the pole, and I then use a quaternion function and set that axis at an angle that I set to here in the channel. And this is just setting a point location for later on. But this is how I got these poles. Next, we'll look at how to get the ropes across. So I take the pole line from over here and copy it to these 4 points that we have set over here. These are also oriented just like the other pole. And we're going to take the middle points and draw lines between them. So from these 4 vertical lines to these 6 lines here. And the way I do that is I go through each of the points one by one in this for loop, and I match up which ones match with rope 0, 1, 2, 3, or 4. So if you see here, we have a 0, or we have 1 here and we have a 1 here. So we want to match those up. And that's what this is doing. And then I just use an add point function to just create new points where those points are supposed to be, as well as removing the lines from before. Oh, and I also create polylines between those points. Next, the reason that I did this is because I want to be able to loop through each of these separately. So I create a loop through primitives, because each line is a primitive. I spawn the start curve on top of these, and I just generate the same curved rope using a sweep here. I also add some extra data for the next part, but for now all I'm worrying about is getting these side ropes set up just by sweeping that curve across these lines. Next I'm going to show how to make the ropes between those ropes. So we take these 6 curves. I got rid of the geometry. It's just by using remove point. I got rid of the bottom row because I'm only going to be creating lines between these two. Delete the lines or the primitives between. And then on the left and right side, I just got rid of whichever one respectively that I'm working on. So I only have to worry about these points here. And then I loop through each of the points and I check to see if the point location matches. So if it's point 1 here and point 1 here, create a line between them. And I do the same thing on the other side. And lastly, I just sweep again, same thing as before, and create ropes that go between. Lastly, we have these pegs with ropes coming out of them. This one's a little bit more advanced. I take those rotated lines that we got from the poles over here again, and I draw a line from this top point, or from this midpoint over here. I draw a line that goes down to the ground at an offset that I set here, so that the line goes outward from the pole. And then I take that line and I draw another line that goes upward at an angle that's away from this one. And finally, I just sweep over this one with a smaller peg. And then I also use this line. I move it up a little bit so that it's not directly into the ground. And I sweep this one as well with a rope. And all put together, that's how I created my hanging bridge asset. Next, we'll look into how to put this into Unity. All right, so I brought my HDA into an empty Unity project, Matt Hanging Bridge, and I'm just going to drag it into my hierarchy. And here we have it. And we can just edit that curve because we set it to editable. And it'll edit very quickly. And we can make the bridge go wherever we want, and it will use this curve to generate the exact curve that we want along this bridge. So if we want something fun like that, it's very easy. And I also included some properties on the bridge so I can increase the width of it. If we wanted a wider bridge, you can also edit things like where the hanging rope goes. If we wanted it to be a little higher, you can also change the offset of where the rope goes out, and so on. And that's it for this walkthrough of my hanging bridge. Thank you for watching.